Welcome to aminacademy.com. In physics, let us discuss about inductance, RC and RL circuits and time constants. Before that, what is self-inductance? A coil can induce an EMF in itself. If the current in a coil changes, the flux through the coil due to the current also changes. That means if inductance is the EMF in itself. That means if the current in a coil changes, the flux through the coil due to the current also changes. This is called a self-inductance. Now let us discuss about generally what is inductance first. Inductance is the tendency of an electrical conductor to oppose a change in the electric current flow through it. The electric current produces a magnetic field around the conductor. The magnetic field strength depends on the magnitude of the electric current and follows the changes in the magnitude of the current. Look at here. L equal mu n squared A over L. This is a formula for inductance, where L is inductance in the henries, H, mu permeability, that is Weber per ampere meter, that is mu, and n is number of turns in the coil, a area of encircled by the coil, and L is the length of coil. These things forms a self-inductance. L is mu n square into A over L. Next, further inductance is the property of a conductor, often in the shape of a coil, that is measured by the size of the electromotive force or voltage induced in it compared with the rate of change of the electric current that produces the voltage. A steady current produces stationary magnetic field. A steadily changing current, alternating current, or fluctuating direct current produces a varying magnetic field, which in turn induces an electromotive force in a conductor that is present in the field. The size of the induced electromotive force is proportional to the rate of change of the electric current. Rate of change of electric current proportional to the change of electric current is, that is, electromotive force is proportional to the rate of change of the electric current. The proportionality factor is called the inductance and is defined as the value of electromotive force induced in a conductor divided by the magnitude of the rate of change of the current causing the induction. What is self-inductance? A changing magnetic field caused by a varying current in a conductor. Due to varying current in the conductor, magnetic field caused by a varying current in a conductor is called a self-inductance. However, also induces an electromotive force in the very conductor that carries the changing current. Such a phenomenon is called a self-inductance. And the quotient of the induced electromotive force and the rate of change of the current is specified as self-inductance. Look at here. Here, a solenoid coil is there. Here, due to AC power supply to the coil, around this what self-inductance is created. Magnetic field due to the primary current flows through it. So self-inductance, coil itself having inductance, it's called a self-inductance. Next is mutual inductance. Self-inductance, the formula EMF equal minus constant into delta I by delta T. Change in current with respect to time into constant is called induced EMF. Here, next, mutual inductance is if the electromotive force is induced in a conductor that is different from the one in which the current is changing. The phenomenon is called mutual inductance, that is exemplified as a transformer. Transformer works under the mutual inductance rule. Look at here. Here the primary coil and secondary coil. Due to change in current in the primary coil, it induces inductance. That inductance is mutually induced the secondary coil also. Even it is not touching, that mutual inductance created from because of the changing current in the first primary coil, and it induces changing inductance in the second coil. So due to that, this factor, this fact is used for transformer. Energy stored in an inductor. And energy stored in the inductor is the magnetic energy that is stored when an electric current passes through it. It's called energy stored. The energy is stored in the magnetic field generated by the current. The formula for calculating the energy stored in the conductor is W equal to half Li square. W equal energy is half L into I square, where W is the energy stored in the conductor in joule, L is inductance in Henry, L is the current flowing through the conductor in meter. Look at here, this is the shading is energy stored. It shows, the area shows energy stored. The energy stored in an inductor is directly proportional to the square of the current and the inductance. When the current through the inductor is reduced, the magnetic field weakens and releases energy, turning the inductor into a current generator. Next is what is RC time constant. RC time constant denoted tau. The time constant in seconds of the resistor's capacitor circuit, that is RC circuit, is equal to the product of the circuit resistance in ohms and the circuit capacitance in farads. It is the time required to charge the capacitor through the resistor from an initial charge voltage of 0 to approximately 63.2% of the value of the applied DC voltage. That means it raises approximately 63.2% of the value of an applied DC voltage. That is, the time taken is called the time constant. Or to discharge the capacitor through the same resistor to approximately 36.8%. That is 100 minus this. It is final charge voltage. These values are derived from the mathematical constant E. Here, next one, RL time constant. The time constant of an RL circuit is the time it takes for the voltage across the component to rise or fall to within 1 over E of its final value. The time constant is represented by the symbol tau and is called using the formula tau equal to L over R. Here are some things to know about that time constant for our RL circuit. Look at here. First one, it response time. What is response time? The time constant measures how a system responds to a step into. Final value. What is final value? After one time constant, the circuit reaches about 63.2% of its final value. That is called one time constant. After about 5 times constant, the system is generally considered to have reached its final values. Next, factors that can change the time constant. What are the factors affecting the time constant? Is the time constant can vary due to changes in resistance, capacitance, or inductance. These changes can be dependent on factors like a temperature. Next, we discuss about exponential function of RC and RL circuits. Now look at here. Consider I equal instant current I in the circuit is I0 into e power minus t over RC, which is called capacitor charging and discharging. Capacitor charging and discharging. Then Q equal Q infinity of 1 minus e power minus t over RC. A capacitor charging. Next is Q equal Q infinity e power minus t over RC, which is equal capacitor discharging. Here it is capacitor charging and this one is capacitor discharging. Next is I equal I infinite 1 minus e power minus t over RC is L over R. This is inductor current buildup. Here E value is approximately 2.718 is the base of the natural logarithm and t is equal to the time constant. The relation for a capacitor gives I equal, therefore you can say from I equal 0.368 I0 and Q equal 0.632 Q infinity and t equal to time constant. Then generally after n time constant, after n times n time, after n time constant, we can write I equal I0 of 0.368 power n in general. So far we discussed about what is time constant, RL and RC circuit. We have done. Please subscribe our YouTube channel.